In this video, we're going to look at how we can solve simultaneous equations where one of them is non-linear. Now we have two options solving these types of equations. One is the graphical method, and the other is substitution. Now, the graphical method is often not useful because it's graphs that we don't know how to draw or sketch, or they need to be very accurate, which makes it very time consuming. So we're going to look at the substitution method in this video for solving equations. So we've got two simultaneous equations here. X plus y is 9, x times y is 8. Now you probably can spot the answer to this, but we're going to look at the method to make sure we know how to do it. And what we do is actually substitute one equation into the other. So we always substitute the linear equation into the nonlinear equation. The first thing we're going to do is rewrite this as y equals 9 minus x. And what that means is now that we know that y is equal to 9 minus x, we can substitute that into here for the value of y, which gives us x times by 9 minus x equals 8. We can expand this to get 9x minus x squared equals 8, and rearranging we get x squared minus 9x plus 8. Take everything over to one side, and we get that is equal to 0. Now we should notice here that we have a quadratic, so we need to solve the quadratic, and the way we solve quadratics is by factorising. So we put in our two brackets, it's equal to 0. We have x and x. These two numbers multiply to make plus 8, and add to make minus 9, which gives us minus 1 and minus 8 are the answers there, which tells us that either x is equal to 1 or x is equal to 8. And these are simultaneous equations, so we need to find y as well. So now we substitute each of these values back into the original equation. This one here. X plus y is 9, so if x is 1, y is 8. If x is 8, y is 1. And we can check that in the second equation as well. 1 times 8 is indeed 8. 8 times 1 is indeed 8. So let's look at this second example. We're going to do much the same thing. We're going to substitute in the linear equation into the non-linear one. The first thing we need to do is rearrange the linear one into x or y equals something. This time it's going to be x equals 7 minus 2y. And then we're going to substitute the x value, which is this, for x here and x here. So we get 7 minus 2y squared minus 4 times 7 minus 2y plus y squared is equal to 1. Now we need to do a bit of multiplying out. We get 49 minus 28y plus 4y squared minus 28 plus 8y plus y squared equals 1. Make sure you can see where each of those terms comes from the equation above into that one. And with a bit of simplifying, that gives us 5y squared minus 20y plus 20 equals 0. So again, we have a quadratic. So again, we need to factorise. Before we do that, we're going to make our factorising simpler by dividing through by 5. Since this is all equal to 0, we can divide through by 5, because everything is divisible by 5. And we get y squared minus 4y plus 4 equals 0. And that makes factorising a lot easier, because we have y now instead of 5y, so y and y, they multiply to make 4 and add to make minus 4, that's minus 2 minus 2. That means that y is equal to 2, and so x, we substitute back in, and we get x is equal to 3. Now you notice for this one we only have one solution, not two solutions. Now the reason for that is if we think about the graph, we can see why. And if we have a curve, in this case the curve is a circle, then there are three things. Either the line might never touch it, in which case there's no solutions, or the line might just touch it and be a tangent, in which case there's one solution, that's this example here, or finally the line might go through twice and cut the circle or the curve twice, giving us two solutions. So the number of solutions tells us something about the relationship between the curve and the line. Either they don't intersect at all, they just touch because the line is a tangent, or they intersect twice. In this third example, we're given a question in words, so we need to identify the important things. We have the sum of the two numbers is 4, so x plus y is equal to 4. The second thing we know is the sum of the squares of the numbers minus 3 times their product is 76. So we need to add the squares together, so that is x squared plus y squared minus 3 times their product. Remember, product means multiplying them together, and we know that is equal to 76. Once we've got that, we need to do our substitution, so we need to rearrange one of them, and we're going to rearrange it into x equals minus y. Could have gone the other way and got y equals, we can do x equals. And that means every time we have x, we need to substitute x out for this expression. So we get 4 minus y squared plus squared minus 3, 4 minus y is equal to 76. Expand that and we get 16 minus 8y plus y squared plus squared minus 12 plus 3y equals 76. Once again, make sure you can see where each of those terms comes from. You might need to do a couple of steps to get there. Make sure you know exactly where each term comes from. And simplifying, that gives us 5y squared minus 20 minus 60 equals 0. But once again, we can simplify that by dividing through by 5 to get y squared minus 12 equals 0. And we can factorize that fairly easily. Two numbers of minus 12 and add to make minus 4, or y and y. If they make minus 12 and multiply them, one is positive and one is negative, and 2 multiply to make minus 12. If we have minus 6 plus 2, we get minus 4. So that means our solutions are y equals minus 2, y equals 6, and substituting that back into our original equation, that means when y is minus 2, x is 6, and when y is 6, x is 2. So that's how we use substitution to solve